We finally made it to the point of nomenclature. No more terminology, no more definitions, no more picking apart little nitpicky things in a structure to be able to talk about them. We're now going to take all of those topics, mold them, and mush them into one big squishy topic, and that squishy topic is going to be called alkanes and nomenclature of the alkanes. So let me give you a set of rules. How are we going to play the game? All right, so number one, select the longest continuous chain of carbon atoms. And this is what we are going to call the parent compound. So that's the number one rule. Every time that we do these problems, we are going to be looking for the longest continuous carbon chain that we can find. And most of the time I circle it just so that I can identify it and I don't forget what it is. And that's what you're going to see me do in these example problems. If you want to do that too, I don't care. Whatever. If it works for you, it works for you. If it gives you the right answer, it gives you the right answer. Why should I care if you have to circle things or not? Number two, number the carbon atoms in the parent chain that you just circled. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There you go. If you have a group, and that group is an alkyl group, and you know what that is now. It could be another carbon or a group of carbons, or another type of group like an OH or an NH2 or something like that. Then that is the side that you begin numbering on first. You give it priority. So if you have this really long carbon chain and you have an OH group that's way over to the left, why are you going to number starting from the right? That makes no sense, right? That OH group is over on the left-hand side. Why don't you start numbering on that side? Because it's closest to the OH group. And that's exactly what we do. Those are the rules of the nomenclature, and we'll see some of those examples. Number three, name the alkyl group, methyl, propyl, butyl, pentyl, and designate the position by a number. Is it on the third carbon? Is it on the fourth carbon? You have a methyl group on the sixth carbon? Those are the things that we have to identify. All right? So what we have to keep in mind is that you have to give me the position and you have to give me the name. That is very important in nomenclature, of course, right? Next, when the same alkyl group branches, happens more than once. You get 2 or 3 or 4 or 5 of the same thing. Instead of naming it again and again and again and again, because that's kind of silly, we use the prefixes like di and tri and tetra and so forth for those. And again, we'll see a few of those examples as well. So for instance, if I have this big long chain, and this big long chain's got 5 methyl groups, why do I want to say methyl, 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 and then the name of the compound? That's silly, right? It's too much time. It's a waste. It sounds silly. I'm not going to do it. So if there's 5 of them, 5 is a penta. So I would call it a pentamethyl. That's how we do it. When several different alkyl groups are attached, I told you before, they really like alphabetical order. So I figure out what's there, I put all the pieces together, and then when I do my final answer, they really like my final answer to be in alphabetical order. So if I have a prop and if I have a bute, then the bute will be written first because B comes before P for propyl. All right, so let's do an example. Here we go. Name it. Whoa. Okay, so using the rules that I just talked about, we need to name this compound. So I need to name this, and I need to find the longest carbon chain. All right, so here's 1 to the left, 2, 3, 4, and 5 if I go down, or 5 if I go across. So that way it doesn't really matter. You're going to get the same name no matter what. So here is my longest carbon chain right there. All right, so there's 5 of them. Do you remember what we used for 5? Pent. And this is all single bonds all the way across. So this is an ane. So this is pentane. But I have this group that's right here, and this group is not part of that main chain that I've highlighted, right? So that means that this is a substituent. It's an attachment, and that attachment we have to name, and that attachment for a 1 carbon is called methyl. So this thing is called a methylpentane, but I'm leaving off something, and that's a number. I have to tell you where that number is going to be located. Well, we said we number the chains, right? 1, 2, 3, 4, 5. Okay, so this is 4. Nah, that's wrong. We said we number the chain, but if there's groups like this, we number closest to that side. And there's only one group that's right here, and that's hanging out over here to the right hand. So this is actually my carbon 1. This is carbon 2. This is carbon 3, that's carbon 4, and this is carbon 5. So on my second carbon, right here, 1, 2, I have a methyl group. So I put a 2 in front of my methyl, and I write the word pentane. Folks, this is what we call the IUPAC name, for this particular compound. This is called 2-methyl-pentane. Now, it also has a common name. I didn't ask for it. It didn't really even say, really, to tell you the truth, but it does have a common name because, look, this is this L group, right? Right there. That's the L. This is an iso unit. Well, what's it an iso of? 1, 2, 3, 4, 5, 6. This could also be called an isohexane. This structure has 2 compounds, or 2 names, that it can go by, and that's okay. But when we look at a name, this name should only clearly identify one structure, and that's it. And 2-methylpentane, no matter how you read it, no matter how you interpret it, can only be interpreted one way and one way only, and that is a methyl group on the second carbon on a pentane parent chain. And this is where 2-methylpentane comes from. If I wanted the common name, it would be the isohexane unit. All right, so here's 2 more examples. We're going to do these as well. I'm going to start with the top one. The top one is longest chain. All right, so 1, 2, down 3. No, I can go further. 1, 2, 3, and then down 4. Or 1, 2, 3, and 4 all the way across. Well, I'm going to keep it simple. I'm going to go all the way across. It's the easiest for me. It's probably the easiest for you. There you go. Wash your hands. You're done. So this 4 carbon is going to be called bute because there's 4, and it's an alkane, so ANE ending. It's all single bonds all the way across. So I've got these substituents here, these substituent groups. Well, this is a CH3. That's a CH3. So this is a methyl group, right? But there's 2 of them. I'm not going to write methyl-methylbutane. That's silly. There's 2 of them, so I write the word prefix di. This is a dimethyl. All right? Now I've got to give each one a number. Do I number left or do I number right? It doesn't matter. Because if I number from the left, 2 in, I get a group. And if I number from the right, 2 in, I get a group. So a number 2 and a number 3 would be methyl-methyl. Or if I number backward, on spot 2 and then spot 3, I get a methyl-methyl. So it really doesn't matter here. I'm just going to number from left to right because of that. It's the simplest. So at carbon number 2 and then at carbon number 3, I have 2 methyl groups. And there we go. 2,3-dimethylbutane. That is the name of this particular compound. Okay? Down below, let's do another example. Longest carbon chain. So I start left-handed. That's normally what I do. 1, 2, 3, and I go down, there's 4. 1, 2, 3, I go up, there's 4. 1, 2, 3, 4, all the way across. Well, that's the easiest. It's still the longest chain. Who cares? Whatever. You'll get the same answer even which direction you go in. It doesn't really matter. It's the same thing. All right, so there's 4 carbons in total. So this 4 carbon is going to be a bute. and it's an ane because it's all single bonds. And I've got to figure out where I number. Okay, I could number 1, 2, 3, and 4 that way, or I could go backward. 1, 2, 3, and 4 this way. Well, I'm going to prefer to start on the right-hand side, and that's because this group is closer to that end, and this group is closer to that end, and I get a lower number when I do that, and that's the name of the game. So I have 2 methyl groups. So once again, this is a dimethyl butane, and at carbon 2, and then again at carbon 2, I have those methyl groups. So here's the story. Here's the rule. Every substituent needs a number. You cannot reduce or condense those numbers down. That means that you cannot simply just write 2-dimethylbutane. Each one has to have its own number. That's the rules. That's what we have to follow. That's what IUPAC says. So we are forced to write down 2, 2, just to confirm that those 2 methyl groups that I have written after those numbers have been identified in their position. We cannot not identify a group by a number. Every one has to have a number that's associated with it. All right? So those are the examples of more alkanes, and hopefully you're seeing that these might not be as bad as what you thought they would be. All right, so here's another one. What on earth is this? Okay, so longest carbon chain. If I start from the left, 1, 2, and go down 3. No, I can do better. You knew that. So I'm going to go all the way across. 1, 2, 3, 4, 5, 6. If I go up 7, if I go over, it's 7. So it really doesn't matter. So I'm going to go all the way across. There we go. And I've got all of these substituent groups here. I've got one there. I've got one here. I've got one there. And I have one here. Right? So I've got to put all these pieces together. 1, 2, 3, 4, 5, 6, and 7. This is a hept, and it's an ane, so heptane, because it's all single bonds, right? And I can number from the left or I can number from the right. So let's just do both and compare them, okay, just so you can see them. 1, 2, 3, 4. Sorry, I'll do that one on top. 4, 5, 6, and 7. All right, so there's one way that we can do it. Let me go back, re-highlight. And then I can number from right going left. 1, 2, 3, 4, 5, 6, and 7. And some people might be confused. Which way do I go? Well, look at your substituents. Look at these groups that are hanging out. And do they gravitate toward one side or another? And as you can kind of clearly see, there's 3 that are kind of lopped together over here on the right-hand side, and one little measly one over here on the left-hand side. So this is a good sign that I probably need to start numbering to the right and then work myself left-handed for that reason. But let's just prove it. If I numbered from left to right, where do my substituents fall? Well, I've got a methyl group at carbon 2, 3, and 4. I've got one at 4. It's right there on top. And then I've got one at 5 that sits down below. And then I've got one at 6 that points up. So 2, 4, 5, and 6 if I go from left to right. If I go from right to left, well, what numbers fall there? On number 2, I get a methyl group, so that's the same. And then at number 3, I get a group, so that's lower than 4. And then at 4, I get a group, that's lower than 5. And then at carbon 6, I get a group, and that's the same. So this choice gives me lower numbers. 3 is lower than 4, 4 is lower than 5. If you add all of these up and you add all of these up, you'll get a lower total with this one. That is another good sign that that's the way that you need to number. So if you're confused about which end to number at, and you can't clearly see that these three are over on the right and this one only is to the left, then write down your choices. Add those numbers up and see which one you get the lower number from. And that's the one that you'll choose to number your system. So these are 4 methyl groups, right? So CH3 is a methyl. There's 4 of them, so that means tetramethyl. And each one needs a number, and we now know what they are. That's a 2, a 3, a 4, and a 6 tetramethyl heptane. Woof! What a doozy, right? All right, so let's take a look at another example. Here we go. So let's try to figure out the longest carbon chain. 1, 2, 3, 4, right? Okay, so this is not going to work. I can do better than that. 1, 2, 3, 4, 5, right? And we're going to name this as a pentane. Careful. Careful. Because there's a different way that we could pick out the longest carbon chain that would include more carbons, and that one's not it. This was a trick. How? 1 carbon, 2 carbon, 3 carbon, 4 carbon. If you go to the left, that's 5. But if you go up, there's your 5th, and you keep going, there's your 6th. This is a 6 carbon parent chain. Therefore, this is a hex, and it's an ane because it's all single bonds. You've got to be careful with those, and they love to give these to you to make sure that you're paying attention. Now let's figure out how to number it. This substituent is a methyl group, right? It's CH3 group. If I number from the right and go down and up and around, this is a 1, a 2, a 3, a 4, a 5, and a 6. So this would be a 4-methyl if that's what I decided to do. However, if I number from here, starting there first, there's carbon 1, this is carbon 2, this is carbon 3, that gives me a lower number. And because of that, that is the preferred numbering way. I start up here at the top first. 1, 2, 3, 4, 5, 6. So at carbon 3, I have a methyl group on my hexane structure that I have drawn. So 3-methyl hexane. Let's look at this one. Oh, they're getting uglier, aren't they? Oh, no. They're getting uglier. They're getting nastier. But folks, take it one step at a time. Take a deep breath. Inhale in and say, I can do this. There's a lot of things that are written on the sheet of paper, but this is not bad. This is not bad. I can do it. I can do it. I just need to use the rules that we talked about. So let's find the longest carbon chain first. I start left-handed. 1, 2, 3, 4, 5. If I go down, that's 6. I can do better. If I go up, that's 6 and then 7. I can do better. 6, 7. If I go down, that's 8. If I go across, that's 8. I'll just keep it simple. I'll just go straight across. So straight across is our longest carbon chain. If you did go down here, you'll get the same answer. There's no difference. Trust me, you'll get the same name. There's no difference in them. But this is an 8-carbon chain, right? 8 carbons in total. So those 8 carbons is going to be an octane. Again, it's all single bonds all the way across. Now I circle these substituents. I see them better when I do that. So on this carbon, I've got this group here. And I also have this group. And on this one, I have that. And on this carbon, I have this. So I'm going to come over here to the side or up on top somewhere, and I'm going to scribble some things down here. This group, this 2-carbon chain that's attached to a bigger piece, this is a substituent. That substituent is going to be called an ethyl group, E-T-H-Y-L, because there's 2 carbons like ethane. It's ethyl. This is a methyl, This also is a methyl, and this Cl is going to be called a chloro. If that was Br, that's bromo. If that was I, that's iodo. If that was F, that's fluoro. They always end in oros, like Zorro, okay? So I need to kind of piece all this together. I've got ethyl, I have methyl, and I have chloro. And they told me in the rules that they really like it when things are in alphabetical order. So C comes before anything else. And that's probably what I need to write down first. So chloro is going to be written down first for that reason. E comes before M, so ethyl would come next, and then methyl would come last. Notice I did not include two methyls. This really is a dimethyl, isn't it? There's two methyl groups that are there. But I didn't include the prefix in the alphabetizing. C comes before E, which comes before M. The di doesn't really mean anything. I don't include that in my ranking. And to be honest with you folks, if you get this backward and you don't write it in alphabetical order, I'm probably still going to give you credit. I'm not that type of person that's going to take off on that type of thing. So now what's left with us is we've got to figure out which side to number from, and I think it's very clear on which side that we should start at. It looks like all of the grouping is over here on this side of the molecule. It's very lopsided. There's nothing really over here onto the left. So why would I start numbering over here to the left-hand side? I'm not going to do that. So this is my first carbon, this is my second, this is my third, that's my fourth, fifth, sixth, seventh, and eighth. So I need to write them in alphabetical order. That's what I'll do. Chloro comes first. So chloro, and the chlorine is on carbon number 3, right? So now you see how these pieces are starting to add together. So 3-chloro. Next, we said ethyl comes next in alphabetizing, E. And that ethyl group is on carbon number 4. So 4-ethyl. And then next are my methyl groups. So there's 2 of them. And those methyl groups start at carbon 2, and the other one's also on carbon 4. So 2,4 dimethyl octane. So the name of this structure is 3-chloro, 4-ethyl, 2,4-dimethyl octane. Oh, I told you it wasn't that bad, right? It's a set of rules. The rules is find the chain that's the longest, circle your groups that you need to name, figure out what side you need to start numbering on, and then put it all together. And if you forget sometimes and maybe put the 3-chloro back here and the 4-ethyl up in front, as long as you're still giving me 4-ethyl, 3-chloro, 2,4-dimethyl, you've got all the pieces. So what if you messed it up? You're not perfect. I'm not asking you to be perfect. So what? I'm still going to give you credit for that, even though it wasn't in alphabetical order. I am not that picky. Well, I am, but not to you, not in Organic 1. This stuff I can ignore and overlook because you've got the majority of the pieces down pat, and that's really all that I'm asking for you, all right? So in the next video, we are going to start looking at names, and we're going to start going backward, and we're going to start drawing structures for them. Some people like this a little bit better, but again, it's going to be more examples, more work, just so you can get a little bit more comfortable with the nomenclature system that's out there for you. So this is where we're going to pick up. Don't take a break. We're on a roll. You're learning nomenclature. Maybe you didn't think that that last set was too bad, and if not, then this definitely is not going to be bad for you either. So come back, join me. I'll be here. I'll be waiting patiently over and over.